Okay, welcome back. So I asked in the previous video for you to consider what comes to mind with these words: convergence, divergence, and transform. So when we talk about plate tectonics, some of these ideas may coincide with what you think, or they may completely diverge, can't use that word, or may fall away from what you think. So convergence simply means come together. Divergence simply means go away. Transform, maybe in what you were thinking was like, oh, to like change from one form to another. The Transformers movie, Michael Bay, gotta love it. But when we talk about transform boundaries in terms of plate tectonics, we simply mean the side-to-side movement. Side to side. Side to side. So it's a little bit different. That's like the main one, I think, that's most likely to be the most different from what you would imagine when that word comes to mind. So when we think about these different plate boundaries on a global scale, this is generally what we see. So the convergent boundaries are indicated by these kind of pink tooth sort of looks. Divergent boundaries kind of look like these little puzzle pieces kind of thing, like these little zigzags. And then transform boundaries are indicated by these little blue kind of offset arrows in a way. So if we were to consider California and the Bay Area in particular, we are actually on a transform boundary. So the Pacific plate and the North American plate are moving side to side, side to side. They're not necessarily moving into each other or away from each other, they're moving side to side. Just north of us is the Juan de Fuca plate, and there is some convergence and divergence happening up there. But down here where we're at, we are on a transform boundary. And I want to talk a bit at length at what these boundaries mean, some of the features that we see at these boundaries, and some characteristics of these boundaries. And I want to start with the divergent boundary, the falling away from or going away from. So a simple divergent boundary is that of the mid-ocean ridge. And I do just want to note, and it looks like it right here in this image, is you can have two kinds of boundaries at the same point. So we have divergent boundaries going on here, but there's also some side-to-side motion as well. So if we were to see like a straight divergence and just like no other movement, this would be a straight line. However, we see it kind of jagged, like some surgeon did a super botched job on this feature, and now it looks all sort of jagged, which is kind of fascinating. And when we look at the rest of the world and how this map is portrayed, to me, this gives some serious Nightmare Before Christmas, like Sally vibes, right? If you have seen that movie, you see how she has like a stitched face. This gives me some of that vibe. So what's really quite fascinating about the mid-ocean ridge is it's really the longest mountain range on Earth. If we were to put everything together, it would range about 65,000 kilometers long, and that's pretty friggin' long, and it's pretty wild. If anyone has spent time in the Rocky Mountains or in the Appalachian Mountains or any of the other mountain ranges around the world, those are dwarfed in comparison to the mountain ranges that are below the surface of our ocean. So I find that to be very, very fascinating. And I want to concentrate for just a moment on this lovely little island here of Iceland. That is literally an island right on a divergent plate. So there's movement happening. There's volcanoes here. You can literally see the splitting of the earth if you ever go, which, by the way, I highly recommend going. It's a very, very beautiful country. It's very expensive, though, so literally start saving now. But it is very, very lovely. Highly, highly recommend going. But it's really cool. It's one of the very few features of a divergent ridge that we see above the surface of the earth. Another feature that we can see at divergent boundaries is called a continental rift valley. So as this split is happening, maybe, it's happening above earth or above water, and then it ends up filling in with water eventually. And we see that in this feature of the Red Sea. So on the east coast of Africa, there's a split happening between Saudi Arabia and Africa, which, I mean, I would split from Saudi Arabia too. I'm just kidding. But there's that split happening between those two regions, and then the Indian Ocean is then able to kind of infiltrate into the area and fill in this landmass or this rift valley. And then that's what we now call the Red Sea, or also the Gulf of Aden, right? So pretty neat what we can see within or on top of these features. And there's even some more divergence happening as well, like in Ethiopia and in other parts of Western Africa. I'm so sorry, my geography knowledge of Africa is quite poor. I know Madagascar, and that's otherwise in Egypt. That's kind of about it. I'm really bad at that. Some really interesting consequences of divergent spread kind of underwater and closer to the mid-ocean ridge is something called pillow basalts. And this is a type of rock feature that we see underwater. It's basically like this magma that's just slowly oozing out of this spread region. And it looks very similar to like weird looking pillows. So it's kind of weird, kind of interesting though, I think. Next, I want to consider transform boundaries, so that side to side movement. And like I said just a few moments ago, we can see transform boundaries at divergent boundaries as well. So if there wasn't this side to side movement, we would see a straight line occurring here, but it looks very, very jagged, right? There's this sort of fracture zone that occurs here. And we actually have a couple of fracture zones off the coast of California, up in like the Mendocino region, which is pretty interesting, which, by the way, if you've never hung out in Mendocino, it's a really cool space. Highly recommend taking a little road trip up there. So this is kind of what we end up seeing. This obviously is a, drawn schematic. To me, it looks like the backside of an alligator or a crocodile. That's kind of the vibes that I always get when I show this photo. But we can see again that if the divergent boundary was not also associated with transform boundaries, we would just see a straight line, but we don't. Here we go. I actually have a photo of the fracture zones above here. So transform boundaries can occur both in oceanic and continental crust. We live on a transform boundary here in California, and the San Andreas Fault cuts through that continental crust, but these fracture zones, meaning these extensive inactive transform faults, often occur and associated with active transform boundaries. So kind of a neat thing here. And then last piece of boundary that I want to talk about is that of the convergent boundary. So the coming together of boundaries. And we can see convergent boundaries actually in all different types of crust. And when I mean all different types, I mean like ocean to ocean, ocean to continent, or continent to continent. And there's some really interesting geological features that we see at each. So the first one is our oceanic to continental boundary. So we have our ocean crust here on the right-hand side, smooshing into the continental crust. And oftentimes we have an active volcanic mountain belt on the continental side. And then we also see these kind of interesting little folds here happening in the land, or in the crust, both on land and underwater. You can think of it this way, like if I were to try to keep one part of my arm stationary and like squish the other part of my arm towards it, you can kind of see how it wrinkles there. Same kind of idea. I know, kind of a weird analogy, but here we are. It's the best I can come up with. But we also often see a trench associated with this. Remember trench? Think of Finding Nemo. Swim through the trench, not over it. Which is quite fascinating. And we actually have this here in our neck of the woods-ish, a little bit north to our friends in the north, but we have the Cascade Range up in Oregon and Washington. Mount Shasta is included in that. But we basically have the Juan de Fuca plate smooshing into the North America plate, which is allowing for this relatively active volcanic region of the Cascades. Mount St. Helens probably being the most notable, which is still, just by the way, like just recently kind of coming back into life, which is quite fascinating. That sucker blew a while ago. Next up, we have oceanic to oceanic. So we have two oceanic plates smooshing into each other. Here we can see a volcanic island arc, which is quite fascinating. We see similar sort of features with like the trench and the sediments kind of smashing together, forming these folds, active magma being pushed up, forming those volcanoes. And the most notable of features here, or perhaps region that you may be familiar with, is the Philippines and a bit of southern Japan and Southeast Asia. So these islands were formed via the convergence of these two oceanic plates, or these several oceanic plates, I should say. There's a lot of action going on here. One closer to home is that of the Aleutian subduction zone, so the Aleutian Islands in Alaska. Lastly, I want to touch on the continent to continent region, and or two plates, excuse me. So two continental plates smooshing together. The most notable geological feature there would be the Himalayan mountains. Turns out that India and Asia did not used to be friends, and then India was like, "Sup, girl?" to Asia, and Asia was like, "Oh, you shouldn't have." And then they smooshed and had a baby and called it the Himalayas, and now we have Mount Everest. So kind of an interesting thing there, and we can really see that quite nicely in the topography of India. So most of India is quite flat, kind of low, and then the Himalayan mountains and the Tibetan Plateau is quite high. And pretty interesting. I love that we can see these geological features within this. So I know that was kind of fast, but thankfully this is obviously a video, so you can pause, go back, refer back to the slides. The last thing I want to end us on real quick is this table that's in your book, which really nicely, I think, separates out these ideas of the plate boundaries, the types of lithosphere they're on. But what I really want you to pay attention to are these boxes that I have overlaid here. So these green boxes indicating earthquakes are present at all plate boundaries, but volcanoes are not present at all plate boundaries. So that is a very important point with all of that. Okay, so with that, thank you so much for watching, and I look forward to seeing you back in class.